Hello, engineers, ladies and gentlemen. My name is Dylan from Devops Uncut, and welcome to another exciting tutorial. In the previous tutorials, we deployed a simple web page on an EC2 instance in the cloud. Today, we shall be taking up a notch. Now, we shall be doing the same procedure, but we shall be implementing the whole thing using infrastructure as code. We shall be using Terraform. Now, I expect you to be able to write Terraform code. I expect you to be slightly proficient in Terraform to be able to understand or go through this lesson. I have picked a very, very simple use case. So we're going to deploy, and build very, very basic infrastructure so that you may understand how Terraform works. When in the real world, it's much more robust and much more complicated. But to do this, you need to understand AWS perfectly because you can't build what you don't know. So I advise any of you watching this to go and learn AWS, learn the infrastructure, learn the networking. You have to learn how things work and how they depend on each other. Without this knowledge and this firm, base, you would not be able to use Terraform efficiently because you have to know what you're doing before you can write the code. So thank you very much, and I will see you at the terminal. See ya. Okay, let's start by creating a README file where we can document today's task. Okay, so we shall use the command touch and file name to create the file. So that's touch readme.md. We'll create a markdown file. That's a file used in Git. It's a markdown format. And here we shall document we carry out today's task. So what is today's task? Well, our task today is going to be to deploy a simple web page in an EC2 instance, which will be in a VPC, a custom VPC, which is a virtual private cloud. Okay, so we shall use Terraform, infrastructure as code. Yes, we shall use Terraform. Use Terraform to deploy. Let me just type this correctly. Sorry. Just to provision an EC2 instance in a VPC and then deploy a web page on this instance in the VPC. Okay. I hope you understand that. The instance will be in the VPC, and we shall use Terraform to create the VPC, provision the instance as well, and then deploy the web page. So that's the task for today. Okay, that's the task for today. So for this task, there are a few things you're required to know already, because this is even though it's basic, but it still requires you to have some skills or some practical knowledge of some things. Anyway, before we start this today, I advise you install VS Code. It's a code editor, which is the one I'm using right now. The good thing about VS Code is that you can write your code in it, and also you can create files and view the contents all in one screen. So VS Code is a Microsoft product. You can go online, download Visual Studio Code. It's a great tool. Okay, and also you need to install Terraform. since this implementation will be using Terraform, you should have Terraform installed and configured. If you go back to one of our old videos, you could see I explained how to configure Terraform so that you can how to configure your AWS CLI for Terraform and everything else. So you need to install AWS CLI as well, and then install Terraform, install VS Code, install Git so you can push your code to your a GitHub repo. Yeah, and AWS CLI is very important because this has to be configured so that you can interact with the AWS cloud programmatically. So we need AWS CLI for that. Install and configure. I did a video earlier where you learn to, or you could follow along to configure AWS CLI to work with the AWS cloud. Okay, so those are the things we need to do before we actually begin any work at all. We want to prepare our environment. Install VS Code, Terraform, Git, and the AWS CLI. Okay. So now, the next thing is we need to think about what we're doing today. What is the task today? Okay. So I will outline this in steps so we can follow along. I'll try and simplify this in a few steps. So I would list all the resources that we shall create with Terraform today. Okay. We shall be creating the following resources using Terraform. So remember we said we shall create an EC2 instance in the VPC. Okay. Now to do this, we have to do other things like the security and the networking. So I would list, as I said, I would list the resources that we need to get this working properly. Okay? Yes. So the first thing we shall need to create is a VPC. As we said, all our resources, everything will be created in a VPC, which is a logical separation of our resources in the cloud. So we have everything in that one VPC. It will be a custom VPC and not the default VPC in AWS. So here are the resources we shall create with Terraform. As I said, the first resource will be our VPC, which is a virtual private cloud. It will just be one VPC. Okay, so we're trying to make this as simple as possible. So we shall create just the minimum required to get this up and running. Okay. So we shall create one VPC. There you can see VPC. It'll encapsulate everything else. Then we shall create one subnet. They can see the subnet. We shall make it public by using an internet gateway and then routing to the gateway. So we shall create an internet gateway, just one internet gateway. Each VPC can only have one internet gateway. Then we shall create a route table for routing to different parts in our VPC. Route table. We shall create routes, which are the rules. The route would have the destination and the target, and in the route table. Then we shall create a route table association. So that way we can actually associate the route table with the subnet. So we know, resources in subnet would use the route table to reach their destinations. And then we shall create our EC2 instance. Remember, that's where we shall be deploying the web page. For this instance, we need to install Apache, and Git. Now, because this is Terraform, remember everything is going to be in code, so we shall write a script. It's called a userdata script. Userdata script. We'll have one in our EC2 instance configuration, and this script will install Apache and Git in our instance during creation. Okay, and then we shall create a security group, which is a firewall. This will control all inbound and outbound traffic into our instance. So yeah, and we shall open our instance to port 80, which is HTTP traffic from the internet, HTTP, and also port 22, which is SSH traffic, which we will use if we want to log in remotely into our instance. So the instance, as I said, we shall utilize a user data script to automatically install Apache and Git. We need Apache because that's the web server which we need to host our web page, and Git we shall use to clone the web page from a GitHub account, the public internet. We shall clone a GitHub account, a public GitHub account, and then copy the index HTML. We shall deploy it to our /var/www/html folder in our instance. After that, we can now use the instance public IP to view our web page on the internet, in the internet browser. Yes. So again, let's just go over this. Okay, here we shall start creating our resources. We're using Terraform, so we shall use a Terraform block, and our provider will be AWS, since this is since we're going to be creating resources in AWS. So we shall create a Terraform block. First of all, let's create a file. This file will host our provider block, so we can call it provider.tf. .tf files are Terraform files. Yeah, so the files must be have a .tf extension or .tf state or .tf vars, TF vars. Yeah. So Terraform block, and then our required provider will be AWS. So let's do the required provider. Remember, Terraform could work with, it's a multi-cloud, so we could use it with AWS, we could use it with Azure, or even Google Cloud. So that for that reason, we need to explicitly state the provider. So we're provider of AWS, and then also we need to state our version and the source for the provider. Now, what this piece of code does is when we run it, it will download the required plugins required to interact with the AWS API and carry out all the configuration and the provisioning of infrastructure. So yes, so that's it. So AWS, the source, HashiCorp AWS/AWS. So this will go to the HashiCorp servers and download the required plugins we need. That's that, okay. And also we need to also have a provider block. The provider block has AWS, and there we shall select the region. Okay. You have to have a region when you're using Terraform. So this region, I'll be using US East 1. That's somewhere in the USA. US East 1 is my region. Yours could be, pick the nearest to you. So provider AWS, region is US East 1. That is now. Yes. Now in this configuration, I'm hard coding just to make this easy, in real world, I will use variables. But let's just leave this way, just for simplicity. So let's do the next file, the networking. So we'll create networking.tf. Here we shall do our VPC and the subnets and everything else, the network. So let us, I'll use the code I've already written and just paste it here. So the first thing is create a VPC. So you can see that's the resource, AWS_VPC. Main is what we've, the alias of the VPC. So we can refer to the VPC with AWS_VPC.main.id. That will give us the ID of the VPC. AWS_VPC.main.id. That will return the VPC ID. So next, we'll do the subnet, AWS subnet. We've called it public. You can see we reference the VPC above. VPC_ID is equal to AWS_VPC.main.id. So you can see we've assigned this subnet to that VPC. So the subnet, so that subnet will be created inside the VPC. The title block is just the network range. So we've done the title block as well, 10.0.1.0/24. Okay, and we've called it main public subnet. So that's the subnet. Subnet is the IP range in the VPC. For this, we're going to use just one subnet, but in reality, you could have multiple subnets, private, public, different types. Next is the internet gateway. Also, you can see it's been assigned to the VPC as well. VPC ID is equal to AWS_VPC.main.id. We've called it main IGW, internet gateway. So we have an internet gateway now. Now we need to create routes. Okay, so we should do a route table first of all. We need to route traffic and packets around to different destinations that we specify in the route table. So create a route table first of all. Also, you see it's assigned to the VPC as well. So it's for the VPC route table, and then we shall create routes for the route table. The routes would have a destination and a target. That's the route. So and the route would reference the route table above. Okay, so we shall see that now. So let's do the route here. Create a route. The route will reference the route table above. So route table ID, you can see, is equal to AWS route table.rtbpublic.id, which is the one above the route table itself. And the gateway ID, you can see the gateway ID is the internet gateway that we also created earlier. So the destination startup block 0.0.0.0/0. That's going to be everywhere, like the internet. And then the target is the gateway ID. That's the internet gateway. As I said, a route, the route would have a destination and a target. Okay, and now we have to associate this route table with the subnet. So that here you can see we have subnet ID and route table inside the route table association. So that way the subnet now has access to the route table and access to the internet. That means anything that's created in the subnet can now have access, can now be reached from the internet. So that's our networking done. Yes, so I hope you understand this. If you don't, go back and learn Terraform. And this is not a Terraform tutorial, so even though I'm making it really basic, we can't. The goal isn't to teach Terraform here, because I assume that you should already know Terraform before looking at this. This is just showing you how to use it to provision an end-to-end provision web page in the cloud. Okay, so that's our networking done. We've created the VPC, done the subnet, done the internet gateway. We've done a route table. We created the routes, and then we did the route table association, and that's the total. That's all we need at this stage for our networking. That's all we need. Okay. So the next thing we'll do is we shall go and create security groups. A security group because we need one for our instance so that we can control access. We can control the ingress and egress. Also, we can create inbound rules and outbound rules. So touch security group.tf. There it's the okay. And now we shall do a security group. Now the good thing about Terraform is that we're creating all these things in different files, but Terraform would execute it as if it was all in one long file. So you can actually group, and manage your files. Group similar resources together, and then they will still get executed as if they were all one file. So that's security group. We've called it my instance SG, my security group. So that's the resource, and yeah. So after this, we shall create the rules next. It needs to have rules. So another resource will be the security group rules, and these rules we shall specify, the inbound rules, what protocols we shall allow in and out. So in this case, we need to have port 80 and port 22. That's HTTP that's the internet. We need port 22 going to be SSH, remote access, and they shall do an outbound. So the inbound is an ingress. So you can see type ingress. That's rule 1, HTTP inbound, rule 1. We can call it anything, but I just use HTTP inbound. It could be anything else. And type ingress from port 80 to 80. So that means, and side block is 0.0.0.0/0. That means anywhere. That means we allow anybody on the internet to come through to our instance, our web page. That's fine. So that's the first one. And you can see the security group ID is equal to AWS security group dot my instance SG. So we have assigned that security group to this instance, to this we assigned this rule to the security group. Okay, so it says security group ID is that is this AWS security group dot my instance SG.id. So that line will assign the rule to the security group, so we know which security group it belongs to. The next one is SSH, port 22. Same thing, allow from anywhere, port 22 SSH. Ideally, it will be our private IP address, maybe, so that make it secure, but this is just for testing and for demonstration. So normally it wouldn't be that open, and then also assign it to the security group. So our security group now has port 80 ingress and port 22 ingress. Ingress just means inbound, coming in. Now, also, because we also want to install things on our instance, to download onto the instance, we need to give it egress, which means allow the other direction, instance to download things from the internet. That's why we have the egress here. Type another rule. Says header block from anywhere 0.0.0/0 and port 00 protocol -1. This way we can download patches, updates, or install things or clone into our instance. Without this egress rule to download, all our batch script will fail because it have no way to install Git and Apache, on the fly while it's being created. So the last one rule is for us to be able to download the web page and also to download and install Apache and Git onto our instance. So that's the whole security group completed. We have done the security group, defined it, and we have defined the rules, and we have attached the rules to the security group. We've allowed port 22, and also we have allowed our instance to download from the internet. Okay, so now let's create our EC2 now. EC2.tf touch.tf file, and start doing the. Okay, oh, sorry about that. We need to use git bash because I need to run the touch command. So let me just leave PowerShell. Go to git bash. Okay. So let's go touch ec2.tf. It could be called anything, but always name your files something meaningful so that you know what's in it even before looking in it. So touch ec2.tf. Here we shall write the code for our instance. Okay. Now an instance needs an AMI. It's also the Amazon machine image, which is like the spec for the instance. It also needs like a key pair. So what I've done here is to have it retrieved dynamically, like on the fly through the code. It's called data sources. So this is it. So data, AWS Ubuntu. Now I put some filters. Filter for the name and its value. Filter for the owner. So what happens is that this script would go to AWS and look for AMIs, images that match these filters, and return a value. I put in the most recent true, so it will return just one, the most recent match for these filters I've stated. So you can see, so rather than hard code the AMI, here it will go dynamically, it will retrieve the most recent image that matches the filters that I have specified. Okay. Let me just show you what that means, how that could be done. Let me go into AMI, machine image. Okay, I've already selected this. Let me just remove them and show you what I've done. Okay, let me just close this once. Close that. Let me just close them. Now you can see I've closed them. Now we have 78,297 AMIs available, public images available. That means we can use this as the base for EC2. So now that's a lot. So we need to filter this, which is why I use the filters in the code. So let's look at the filters again and see how we can reduce the numbers of and the number of matches. So let's get the name first of all. Let's look for AMIs that match this name I've selected. So Ubuntu images, VM, SSD. Okay, let's go AMI name, search. AMI name, yes. Let's look for equals, and let's paste this here and search. You'll see it'll reduce the numbers totally. Okay, now we have 105 matching. We've gone from 78,000 to 105. Brilliant. So now let's go on and look for another filter from our code that we use just to show you why I use the code. The owner. Now that number there is the account ID for the owner of the AMI. So I would copy this, go back there and look for the owner in the filters, and further reduce the results. Okay, let's go back to the console. their owner. That's owner, okay, equals. Okay, let's search. From 105, you should go down 59. Not bad. So now we have just 59 results. So out of 59, it will return the most recent. So that's good enough for the purpose. The next thing we're going to retrieve dynamically is the key pair. A key pair is needed for SSH access to log into our instances for troubleshooting or for anything else. So I have a key pair already in AWS. That's why I haven't created one from scratch. So the key pair is called my EC2 key pair. So this will go there and find it and assign it to key underscore name. Okay, so my key pair will be assigned to key underscore name, to that variable, and I can use key underscore name in my EC2 instance as the key pair. Okay, so that's so now we're going to retrieve dynamically the key pair and the AMI. So now let's start with our resource, our EC2 resource itself, our instance, which is the virtual machine. It is the compute power of the whole thing. Okay, so I'm just paste it here. Forget IDs. So that's a resource AWS instance. I've called website. Now you can see the AMI. It says data.aws.ami.ubuntu.id. Now the AMI it says data because it's retrieved from the data source, which we did earlier. Here you can see data AMI Ubuntu. Same thing, just add a .id. Data.ami Ubuntu.id. Okay, so yeah, instance type T2 medium, that's fine. Now VPC security group ID, that's the ID of the security group we created earlier. So that's the ID there, so that we've assigned that security group to this instance. And the key name, which is the data source, and assign the key name to the key name variable. Yes. Now you can see where it says user data. Now inside this is our bash script. So during installation of EC2 creation, this script will execute. It would execute. That's why you have the shebang /bin/bash to indicate that this is a bash script. Okay. So I would explain this as I go along. So that's okay. So now that's the user underscore data. That's our script, which will automatically execute during creation of the EC2 instance. This which I use to install and deploy. That's a very powerful script you're looking at right there. You do a few things. First thing first, we shall use the apt. Apt is the Ubuntu's package manager. First of all, we use sudo apt update. So we update all the packages and dependencies. The next, you can see, we say sudo apt get install -y Apache 2 and Git. That will install Apache 2, the Apache web server, and it will also install Git onto our instance. And the systemctl start Apache will start it, and then we'll enable it, so it's running. When you start, it'll start running. When you enable it, if we have to stop our instance and start again, if it's enabled, it will start running automatically. Okay. So the first part is to update the apt package, and then we use the package. We install Apache and Git. We start the system, and then this is the part where we use Git. So Git, we shall clone this GitHub repo. That repo is what contains. Repo hosts. It's a GitHub repository that hosts our index.html page, our web page. So this is going to clone it into the temp folder, temp/host web page EC2 Terraform. It's going to so it's going to clone it from the internet, like download it and copy it. Basically, it's going to copy exactly to the other folder. Yeah, so let me go into my repo where we've hosted this. It's hosted here. Okay, so go into repo repository. Okay, let's go there. Host, okay, it's the first one on the host web page, EC2 Terraform. Let's go into it, and there we shall see index.html. That is the web page that we need. There, you can see index.html. So that and this is the content, the web page. Yeah. So we are going to get the code. That's to clone. That's the URL we need to clone, and that's what we use in the git clone command. So that git clone, that's the URL we put in there to git repo, and so we're going to clone that whole thing down onto our instance, clone it into a temporary folder. Let me show you that. So let's slide this to the side a bit so you can see it properly. So I'm trying to understand what's going on. We're cloning from Git and then clone into this temp/host web page EC2 Terraform folder. So we're cloning from the internet down into that folder. Let's just hold it temporarily. And then we shall extract the index.html page and deploy it to a /var/www/html/ which is where Apache serves web pages. So to be able to have a web page, active and reach from the internet, it has to be in that folder. So next you can see the command sudo mv. That means move. That means move the index.html file from this location to /var/www/html folder. So that does it. And then after it's moved, we now use sudo. The chown just means change ownership. So we give ownership to the user running the script, so that way the script can be reached at any time. Without the right permission, we might have problems when trying to reach it. Okay, so that is done, and we've done everything to do. So we have moved index.html to the folder where it to be served as a web page. We've moved it to /var/www/html. So that's about everything we need to do to get our web page up and running. Yes. So all this script would execute as the instance is being created with Terraform. So now we're going to begin to run our commands, and let's start to build our infrastructure. Okay, so we need to run Terraform init. This command will initialize our local machine. It will download all the plugins we need. All the plugins we need to access the AWS API. It will download any models, and it will also initialize our local backend. The local backend is what stores the .tf state file, which keeps the current state of our infrastructure. But for now, what this will do to create a .terraform folder which contain information about our provider, plugins, and nothing else. So let's go initialize Terraform init. That's the first thing we do. So this will initialize our working directory. Okay, so there's the backend, as I told you, the backend. The backend contains the tf-state file. You can see tf-state. Yeah. It will initialize the provider plugins, and it's been initialized. Okay. Let me clear the screen so we can see better. Next, we shall run Terraform validates. What this will do, it will just validate the syntax to make sure I haven't left something out of my code, maybe a comma or something, maybe some space, something not right. So Terraform validates. You can skip this validate, but I do that just to make sure to save me time later, discovering that I have left something out. Validate, we'll do a quick check on all the code you've written, make sure nothing is wrong. Just the syntax. It doesn't check the execution, just the syntax. Yeah. Validate success. It is valid. So we're good to go. Now let me clear this again. Yeah. Now next we shall run Terraform plan. Terraform plan, what it does is that it will show you what resources are to be created. It's like, it gives you like a dry run. It tells you what to be created. You can see the resources. So basically, it gives you a chance to review what you're doing before you apply. So that way you can know if something is wrong, if it's as intended. Terraform plan. There we go. And we'll start planning. Okay. So let's see. It's working in the background. Let's give it some time. Give it some time. Okay, now you can see it's planning. Now you can see it's told us 11 to add. That means it's planning to provision 11 resources. Let's go through and let's see together. See what it's doing. Okay, you can see it's going to create the instance. Yes, instance, yes. Going to create an internet gateway there. It's going to create the route, AWS routes. That's a route table, route association. That's the security group. That's the security group rule. Remember the rules. Another rule. There are 3 rules. Another rule. 3 rules. That's the subnet. Remember in the VPC, and that's the VPC. So it's creating all what we all planned to do. So there. So I'm happy with the plan. Let me clear this so we can see properly. So now this is the main command. I will run Terraform apply, and this will actually execute and actually create those resources in AWS. Okay, so let's go Terraform apply. Now I will add the option auto approve, because when you run this, it would ask you it's stop halfway and ask you if you want to, if you're sure you want to run it. So by putting adding the option auto approve, it will skip. It will just by default it will run without asking you the prompt. It will assume that you have selected yes. It will approve it automatically. So Terraform apply auto approve, and now, ladies and gentlemen, our resources are about to be created. There we go. So let's wait and see as our resources get created in AWS. Yep. So it's working. Now it's creating, you can see. It's a plan, 11 to add, 0 to change. Now it's creating. It's creating the VPC. It's creating. That's the beauty of Terraform. Just watch and see what it does. It's creating security groups, creating the route tables, creating. Yes. how long this takes varies depending on the complexity of the infrastructure. Could take from a few, just a few minutes. Sometimes could take up to 30 minutes. Now, apply complete. Resources 11 added, 0 changed, 0 destroyed. That means that we have created the resources in AWS. Okay? And now that our resources have been created, we have, you can see there, it says apply complete. Resources 11 added, 0 changed, 0 destroyed. So now we shall go to the AWS console and verify that they have been created. So let's just head towards the console now and verify this. Okay, so first of all, let's go to our instances. That's the EC2 instance created. See if it's up and running yet. Yes, you can see it's my EC2 server, my EC2 server. It's running, EC2 medium. That's running there. It's still initializing. So it's running the scripts we had before, executing the scripts. But you can see it is running now. It has a public DNS already and everything else, public IP. This public IP is what we should use on the browser to view our web page when it's completed. Okay, so you can see our instance is being created. It's already running, but it's still initializing. So let's leave that there. So we can see instance done. Let's go to our VPC. Okay, now we should have two VPCs now, two VPCs because there's a default one that comes with an account, and then we have created one which we call them VPC main. So let's check the VPCs that we created. VPCs. So most likely we'll see two there, the default one and the one we have created. Hold on while this loads. Gets in two. Yes, as I predicted. Let's go into this and see. It's been loaded. You can see main VPC. This is the one we created, and the top one is the default. Yes, so you can see default. The top one says yes. Default. The bottom one says no because it's custom. So our main VPC is there and has been created successfully. Okay. What else? We created a subnet. Now let's check the subnet. So there are probably 7 subnets now because the default comes with 6 subnets for our default VPC, and we've created one to make it 7. So let's check. Probably have 7 VPCs there now. Yes, that's 1, 2, 3, 4, 5, 6, 7. This is the one we created there, main public subnet. So that's yes, that's our subnet there. You can see it's in main there, so that's our subnet. Let's check the internet gateway. Internet gateway we probably have 2 there now. One is the default, and one we've created IGW. Let's check internet gateways. There'll be 2 sitting here now. Yes, the default one, that's the default. If you go there, it's default one below. This is what we created, main IGW. So that's done. What else did we create? We created the route tables and everything else. Let's just know what else we have done here. Gateways. Let's check the route tables. There'll be 2 route tables as well. The default and the one public route table which we created. That's the default. These are default ones. Let's see the top. Okay, one from the previous project 2, but this is the one we just did today. The public RT. That's the public route table we just did. So that's fine. If we click on this, we can look at let's go into this, the route table. And there we shall see the routes. These are the routes we created. Remember, destination and the target, the internet gateway, allows us to reach the internet to get to our instance. So that's it. Destination target. So that's correct. What else have we done? We created a security group. Yeah, okay. I think there might be two now. There's one. I think one the default one. Yes, and then we created one called I think it was main SG. Let's go into that. Security groups. Yes, this my security group. That's the one we created at the top because these two are defaults, so we don't touch those ones. But we created the top one, my security group. Can you see managed by Terraform? So yes, that's our group. Now we go there. Remember we created two ingress rules and one outgress and one egress rule. So let's go into the security group and we'll see the rules. So let's look at the inbound rules. There should be two, port 80 and 22, which we created, if you remember. So that's SSH HTTP. You can see they have port 80 and 82 inbound. And we created port 00-1 for the outbound rule. Let's check the outbound rule now. Outbound rules, we did one, so we can download patches and things from the internet. That's one. Allowed all traffic. Yes, that's the outbound rule we did, which is correct. So you get to that everything we created, we have just viewed. So our VPC is up and running. So now let's now check and see if we can view our sample web page. Okay, so we need to retrieve the instance's public IP address. This is what we shall use to we shall run this on the browser to see our web page. So let's go back to EC2. We want our instance. That's my EC2 server. We need to grab its IP address. I hope by now it's finished because it needs to be running fully before we can actually view anything. Because it needs to run and then install all the prerequisites, install everything, Apache, Git, and everything else. Okay, let's see if it's still, now it's saying there's a status. 2 out of 2 checks passed. So now it has run to completion. So everything should be up and running. So now we need to grab its public IP. So let's just click on this and scroll down. We'll get a public IP. Hold on. Open this up. Details. This public IP. Yes. That's the public IP address. So we click on that, copy, and we go to a browser. So ladies and gentlemen, the moment of truth. If everything has worked properly, I will paste this, enter, and we shall see our web page. So there we go. Brilliant. Congratulations. You have created your first web page in the cloud. Terraform rocks. So thanks, ladies and gentlemen. And this has been good for me. I hope it was for you too. Now you've seen how we can deploy a simple web page in the cloud using Terraform. We used Terraform, we created a VPC, we created subnet, security groups, we created all the infrastructure we needed, including the virtual machine, the EC2 instance, and then we also used Terraform to grab our code for the web page from Git and installed it on Apache. And we have viewed it. So listen to me, that's the power of Terraform. Sorry, before I go, you need to destroy all your resources. Okay, you need to destroy them because or else you'll be charged. So don't forget, whatever you do, as soon as you finish this demonstration, ensure that you destroy your resources to avoid being fined heavily for this. Okay, because you will pay for all the resources running in the cloud. So let's do this with Terraform. So I will go back to the console. So the terminal, sorry. Okay, so let's go to terminal, VS Code. Yes, there. Okay, now we're there. Let me clear everything so we can see what's happening. It's cleared, okay. So now to destroy our infrastructure, all we need to type in is Terraform destroy. Terraform destroy, and I will use the option auto approve. This just stops us from having to pause halfway to approve this. It will automatically approve itself, and it will just run uninterrupted. So Terraform destroy to approve is the command we shall use to destroy our infrastructure. Let's go. Now you will see everything being destroyed. Because if you leave this on overnight, in the morning you'll be shocked when you see how much you have run up. The bill would have the bill will have risen overnight. So try not to make sure you always destroy the infrastructure after an exercise. Okay, it's plan 0 to change 11 to destroy, so it's destroying. There it is now. It's destroying everything. After it's destroyed, we shall go back, and you'll see that everything's gone. So that's the power of Terraform. It might take a while to actually write the all the code and everything else, but once you've done that, you can run, destroy, and create again in seconds with the same configuration. Okay, it says destroy complete, 11 destroyed. Okay, so let's go to the console, and we shall see whether or not everything got destroyed. Okay, so hold on. Let's just okay. So let me come back here. There. Let me take this off. Let me refresh. It's for the EC2. Refresh this. Let's check the instance first of all. We're checking the instance to see if it's still there. We're still running. It shouldn't be. Hold on. Here you can see it says terminated. Yeah, it will stay this way for a couple of hours, but it's gone. It's terminated. So we know that's gone. Let's go to our, what else can we check? VPC. That should be gone as well. It will just be the default VPC remaining now. Let's see. VPC done. Let's see if it's still there. Shouldn't be. See, it says VPC, just one VPC. That's the default one. The one we created has gone. Yes, so see, that one's gone. It's just the default one now. Default, yes, for VPC. Yeah. So everything, all the subnets, it's just with the 6 default ones left. Our subnet, yes, our subnet, ours has gone. The route tables, everything will be gone. That should be gone as well. It will just be the default. Yes, that is no. So you can see all we created should have gone. Let's check our security group. NSG should have gone. Just the 2 others left. Let's see. Yes, it's gone. NSG is no more there. So yes, it's just the default VPC security group there. So you can see we have done everything, all destroyed. Now if we go back to the web page and refresh, it'll be gone as well because we have destroyed the infrastructure. So refresh and see what happens. Okay, come on, refresh. It's refreshing, spinning, and it might time out because it can't find the page anymore. page has been destroyed. Yes, it can be reached. Error connection timed out. So you see that timed out. So that means everything is done. So I hope you enjoyed this. Don't forget to subscribe to this channel, because in the next video or two more, I will be using Terraform to create a more robust setup. Okay, so I hope you enjoyed this, and I'll see you again soon. Thank you very much. It's Dele from Devops Uncut. Thank you.